Hello everyone, welcome back to the another session in series of learning design and analysis of algorithm. And this video will be going to discuss about the time complexity. In the previous videos we were discussed about what is algorithm and how we can write algorithm. So usually one problem will have many solutions, and each solution we are considering as an algorithm. Now to calculate the performance of such an algorithms, so we'll be discussing that how to calculate the performance, that is space complexity and time complexity. In the previous video we covered about space complexity, and now today we'll be going to discuss about what is time complexity and how it can be calculated. Now, so time complexity is what? The amount of time which is required to execute the source lines of code. Okay, if I'm writing a program, so let's take the example that I'm writing a program to add two numbers. Okay, now how I'll take two numbers as I'll take t1 comma I'll take t2. Now I'll take one more number t3. Now t3 is equal to t1 plus t2. Fine. So this is the algorithm, and this algorithm to add two numbers, two simple numbers. So algorithm add t1 comma t2. Okay. Now, so we will be writing some algorithm, and this is my algorithm, and this algorithm is to solve a problem of adding two numbers. Now we will be writing some lines of code, right? And this lines of code is called as SLOC, source lines of code. The lines what I am writing, these lines are called as SLOC. So each line will take some time to execute. So that is what the time complexity. What is time complexity? The amount of time which is required to execute the source lines. So to execute this statement I need some time. To execute this I don't need some time. It is only the space, right? Now to execute this I need some time. To execute this also I need some time. So the time complexity of this is what? So that we will be going to calculate. So now time complexity basically can be calculated by using two methods. The one is step count, the other one is frequency count. The step count means when you initialize a variable, when we initialize a variable, so let us talk that the variable is count of 0. Now this count variable will increase by 1, right, depending on the program. So step count means that we will be counting, or we will be increasing the count variable from 0 to the next level. So that is increasing by 1. That means we will be telling or count is equal to some count plus 1. So this is what step count, and this 1 indicates step count of 1. If I write here count is equal to count plus 2, then that indicates 2, means the time complexity is also 2. Okay, the step count, this one indicates the step count. Now let's see the example for the better understanding. So usually this example we will be discussing in the class also, right? Sum of x comma n. Now here if you look at, now I wanted to add array of elements with n size. Okay, now so I have taken total is equal to 0, and for some loop, and I am updating the total value, and this was total plus I, not 1, it is I. Okay, this is what the basic algorithm. Now in order to calculate the complexity of this algorithm, I am just putting this count. Wherever I am getting the count, there we will be putting the statement. Okay, now sum x comma n, begin total equal to 0. So till this three statements we did not have any count variable. Okay, now when you come to this count total is equal to 0, that as you have one variable, one count has been increased. So to execute this line total is equal to 0, to execute this line we need some time, right? We will require some time to execute this line. So my count has been increased by 1. So initially count is what? 0. So till then, till no variable is there, so till this line till this line, sum x comma n begin. So till then I don't have any variable. So my count is as usual 0. So when I have taken total is equal to 0, my count has been updated. So till then it is 0. Now when I have taken this variable, now my SLOC got increased, right? So I need some time to execute this line of code. So my count variable has increased by 1. My step count has been increased by 1. Fine. Now, so now come to next line. This is one loop. So here for every iteration of I have to update the count variable. So this is one variable where I have updated count, and this also one more variable coming into the picture. So as soon as you are updating I values, your count variable will be increased. So now count is equal to count plus 1. It indicates what? I value. It indicates I value. Now total is equal total plus I, and this also updating. So in turn your count is also updates. So when you come out of the loop, again number of operations are in the loop were increased. When you are coming out, your count will get updated again. So the mean of this is, as you are putting SLOC, source line of code, into the program, when you are executing some line, it means that one count has been increased. That's it. Count is just like a counter variable to know how many times the variable has executed, the line has executed, to know it. So in simple task we were written in this way. Now let's look at. So here if you find it, it was 2 times, right? Like in body of the loop you have used count, and outer of the loop we were used your count. So outer loop, this is one count and this is one more count. So total how many times count has updated outer loop? So count has updated outer loop, count is equal to count plus 2. So 2 times we updated the count. Fine. And inner loop, how many times we updated? This count is for I and this count is for total. So again in inner loop we were written count variable. The step count has increased to 2. So that's what outer loop is having 2, inner loop is also having 2. So the total time complexity is what? 2n plus 2. Now this is what constant time, because we did not have any looping concept here. It is one constant time. So as it is step count of 2, we need 2 cycles of time to execute this SLOC, right? Now when you come to this thing, that my count has been increased with 2, but how many number of times I have to do this operation? N number of times. If it is count plus 1, then it would be of n only. As it is count plus 2, now my loop will repeats for n times and my step count is 2, hence it is 2n. If it is count of plus 3, then my step count will be 3n. If it is count plus 4, then my step count will be 4n. Yes. Now, so now this is what the constant time, which is 2, and this is what your loop time, which is 2n. So the total time complexity is what? 2n plus 2. Yes, did you understand? Now this is all about the time complexity first method. And let's see about the second method, frequency, how we will be calculating time complexity using in the second method. Now frequency count will be calculated SLOC and the frequency count. The mean of this frequency count is, generally we'll execute one statement for single time, right? In the previous example we were seeing this. How many times this statement will get executed? One cycle. It takes one cycle time and it takes one cycle time. Why only one cycle time? As I did not mention any loop to repeat the task, it takes one cycle time. So if I have any loop, then it takes the condition number of times, right? Now let's see the example. So algorithm sum x comma n, total is equal to 0. For loop, total is equal to total plus 1. Now what is the SLOC here? Now respective to the time complexity, so respective to the space complexity, it will differ. The SLOC will get differ. So respective to the time complexity, SLOC is, source lines of code, executable source lines of code is this. So this is what the function name and open brace, so leave that one. So total equal to 0. Now it is a variable and it is source lines of code. We will be executing this thing, right? Now, so it takes one cycle. Now this also SLOC. So as of SLOC is concerned, we won't talk that how many times it will get execute. SLOC means that whether it will execute or not. That's it. So a general meaning of SLOC is it should be a part of program. It should not be a comment line. But here we were given executable SLOC. Okay. So the time which is required to execute the particular line, that will get added to the time complexity. So total is equal to 0, one executable line. Loop is one executable line. Total is equal to total plus I is one executable line. So total steps, how many steps we do have? 3 steps per execution. Now let's see the frequency count. What do you mean by frequency count? That how many times one statement is being executed. That is nothing but frequency count. So total equal to 0. To execute this line of code, we do not require that much of time. So we'll take one cycle per minute, one cycle. Now let's see this one. The very important part of time complexity is when you are using a loop, you have to be bit conscious that, so for I is equal to 1 to n. So when, let us take the example that my n value is 5. Okay, my n value is 5. So I is equal to 1, 5 less than 5 is greater than 1, condition is true. So it is one cycle, right? Now I value has been increased and I is equal to 2, 2 greater than 1, and time cycle is, again it is 1. Because for each instruction it takes one cycle time. So for I is equal to 3, it takes how much? One cycle. For I is equal to 4, it takes 1. For I is equal to 5, it takes 1. As the condition is what? It is 5 greater than or is equal to I value. So now here, when the condition will get failed, when it becomes n plus 1. So when I becomes to n plus 1, as I hits to n value, the condition will be true and it will come to this. So it executes, for loop will execute n plus 1 because 5 true conditions, 1 false condition. So I is equal to 1 to n, all true conditions. For all true conditions, body of the loop will get execute. There will be one false condition that will get compared, that will get checked here, and that is of n plus 1 comparisons. Okay, the moment when n value will go to n plus 1, that means the moment when I value will cross n value, that means when I becomes 6, n is 5, then condition will get failed. So even this statement will be compared. That means when it is failed, then only the body of the loop will not get executed. Right? Are you following? Now the total comparisons are what? N plus 1. For all the loops, total comparisons will be n plus 1. Now how many times this statement will get executed? N times. For I is equal to 1, condition true will execute this. So one cycle. For I is equal to 2, will condition true will come inside to execute. So how many times will execute this statement? N times. The total time complexity is what? SLOC into frequency count. What is your SLOC? 3. Okay. Into your count. What is this count? 1 plus n plus 1 plus n. Right? 1 plus n plus 1 plus n. Total 2n plus 2. And this is what your constant time. Constant time. Right. Now look at this. The total time complexity of this is 2n plus 2. Okay. If you don't have this total is equal to 0, then what is the time complexity of this? Then it would be of n plus 1 itself. 2n plus 1, right? Okay. So this is what the frequency count. So here one more example is there. You can also look into this example. Okay. So it is normal one variable. So it is what SLOC, and these are what the time complexity what I have taught you in the above. the total time complexity is 4n plus 2. Have a look. Fine. Thank you all. You can take many more examples to practice time complexity. If you have any questions, you can put in comment box. Thank you.